Hi everyone! Today we are going to start the study guide for 8.1 to 8.3. Remote learners, remember if you are taking your quiz at home, you are expected to take it during your scheduled geometry period. So number one, we want to fill in the table below. If we look at this table, we notice that we have the names of the polygon, then we have the sum of the interior angles, which we have an equation for. And the equation is n minus 2 times 180, where n represents the number of sides. And then the last column says if the polygon is regular, remember that word regular means same, the sides are the same length and our angle measures are the same, then what's the measure of each interior angle, which would be the equation n minus 2 times 180 divided by n, the number of sides. All right, so let's start with triangle. So how many sides does a triangle have? Well, we know that that is 3. So I need to plug in 3 to my equation, which we get 3 minus 2 times 180. If you plug that into your calculator, you end up getting 180. All right, so now to find the measure of each angle, if it's a regular polygon, I'm just going to take the sum, which we found out was 180, and divide that by 3, which is the number of sides, and we end up getting 60. Let's try this again with a quadrilateral. We know that a quadrilateral, the sides are 4, so I need to plug 4 into my equation, 4 minus 2 times 180, and that is equal to 360. Now if I want to figure out one individual angle, I need to do 360 divided by the number of sides, which is 4, and you end up getting 90 degrees. Octagon, how many sides are in an octagon? Well, we know that that is 8, so I need to do the same thing. Let's do 8 minus 2 times 180, and when you plug that in, you get 1080. Now, if this was a regular octagon, what's the measure of just one interior angle? Well, I need to take my 1080, divide that by the number of sides, which is 8, and we get 135. All right, now we know the sum of the interior angles, which is 1440. I don't know the name of the polygon, and then I need to figure out the interior angle, just one of them. So let's start with figuring out what is the name of this polygon. Well, I'm going to use my same equation up here, but now I know what this is equal to. So I'm going to have n minus 2 times 180, and I know it's equal to 1440. Sorry, I'm running out of room here. What's my first step here? Well, I need to divide by 180 on each side. Divide by 180. That gives me that n minus 2 is equal to 8. Then I need to add 2 to each side. We end up getting that n is equal to 10. So what is a 10-sided polygon? It is a decagon. So decagon. So now if I want to figure out each interior angle, I'm just going to take the 1440, divide that by the number of sides, which we know is 10, and we end up getting that each individual angle is 144 degrees. Next, we know that the polygon is a 16gon, meaning that it has 16 sides. So once again, let's find the sum. If you do the math, you get that it's 2,520. And if we're trying to figure out the individual angles, we're going to take 2,520 and we're going to divide that by 16. And we end up getting a not so pretty answer, but that's okay, 157.5 degrees. All right, and our last problem here Now we know the measure of each interior angle. I need to figure out what is the name of the polygon as well as what is the sum. So remember, if I scroll up here, this was our equation for the third column. So I'm just going to set 171 equal to this equation. So I'm going to do that over here. So 171 is equal to n minus 2 times 180. Divide that by n. So now the first thing I want to do here is I have a division of n. So I want to get rid of that. So the opposite of division is multiplication. So I'm going to multiply each side by n. So those cancel out. And I'm going to kind of rewrite this to make it pretty. So 171 times n is 171n. And that's going to be equal to n minus 2 times 180. Sorry, that's really sloppy. All right, so now I still need to get n by itself. So what I want to do is I want to take this 180 and I want to distribute it inside the parenthesis. So that gives me 171n is equal to 180n minus 360. If I subtract 180n on each side, that will cancel this out, and I'm left with negative 9n is equal to negative 360. Divide by negative 9 on each side, and I end up getting that n is equal to 40. So this means that I have a 40-sided polygon, which we're just going to call a 40gon. So now that I know the sides, I can use n to find the sum of the interior angles. So that's going to give me 40 minus 2 times 180, and that is 6,840. All right, number 2. In quadrilateral LMNO, the perimeter is 61. Is LMNO a parallelogram? Explain why or why not. All right, so if we look at our diagram, we are given side lengths, and we know that opposite sides of a parallelogram are congruent. So this side and this side would be congruent, and this side and this side would be congruent. So let's set these equations equal to each other and solve for x. So with the first one, I have x plus 6 is equal to 2x plus 1. I am going to subtract x on each side, and that gives me 6 is equal to x plus 1. Subtract 1 from each side, we end up getting that 5 is equal to x. All right, now let's look at our other side length and see if we get the same x value. So I have 3x minus 24 is equal to x minus 6. I'm going to subtract x from each side, and we get 2x minus 24 is equal to negative 6. Add 24 to each side, we get 2x is equal to 18. And divide that by 2x is equal to 9. I have two x values that are not the same. So this is kind of our hint that this is not going to be a parallelogram. If we have two different x values, that doesn't make sense when we're working with the same equation. And then if I were to actually plug in these side lengths, so for these two, I had that x is equal to 5. So that would mean this is 11, this is 11. And for these two equations, I had that x is equal to 9. If I plug that in, I would get 3 and 3. Well, if you add these up, 3 plus 11 plus 3 plus 11, that does not equal 61, which is supposed to be the perimeter. Therefore, this is not a parallelogram. So I'm going to say no. This is not a parallelogram. Why? Well, one, our side lengths, the x values are not the same, meaning that the opposite sides are not congruent. And so since the opposite sides are not congruent, this would not be a parallelogram. For number 3 here, we want to find the values of x. If we look at this diagram, we notice that we are given the exterior angles, and the sum of any polynomial, their exterior angle is equal to 360. So I'm just going to take each exterior angle and add them up. So that gives me 64 plus 60 plus 69 plus 42 plus x plus 23 plus x is equal to 360. Let's combine our like terms. So let's start with the x's. I have 1x here and 1x here. That is 2x. If I add up everything else in my equation, I end up getting 258. This is all equal to 360. Subtract 258 from each side. I get that 2x is equal to 102, meaning that x then is equal to 51. And that's it. All right, number 4. Consider an octagonal stop sign. It's a regular octagon. So let's start there. An octagon. How many sides does that have? We know that it is 8. Find the sum of the interior angles of a stop sign. So I need to use my equation, n minus 2 times 180. So that will give me 8 minus 2 times 180. So when I plug that into my calculator, I get 1,080. Find the measure of one of the interior angles. So that means I need to take my sum and divide that number by the number of sides, which is 8. So 1,080, divide that number by 8. And let's put n by 8, and that will give me 135. So each angle in that stop sign is 135 degrees. And then lastly, find the measure of the exterior angle of a stop sign. Well, if one measure of the interior angle is 135, and we have an exterior angle. So let me sketch this out. So here's my octagon. If this angle right here is 135, I also have this exterior angle here. So we know that the interior angle and the exterior angle create a line. They're a linear pair, meaning they add up to 180. So if I have 135 plus x, which is that exterior angle I'm looking for, it's equal to 180. So if I do math there, I end up getting that x is equal to 45. So the exterior angle is equal to 45 degrees. We could have also done this by taking 360, which is the sum of the exterior angles, and just divided by the number of sides, which is 8. If you do that, you'll also get 45. In quadrilateral JUMP, the angles have the measures as marked. Is JUMP a parallelogram? Explain why or why not. So for this diagram, we are actually given angle measures, and I'll move this over a little bit so we can see that. And if this was a parallelogram, we would know that the opposite angles are congruent. So that means that J and M would be the same measure, and P and U would be the same measure. So let's start by looking at J and M and set those equations equal to each other. So 3x plus 7 is equal to 2x plus 40. If I solve for x here, I end up getting that x is equal to 33. Let's look at the other two opposite angles, U and P. So I'm going to set those equations equal to each other. So 4x minus 58 is equal to 2x plus 8. And if I solve for x, I end up getting that x is equal to 33. Unlike the other problem, we got the same x value for both those equations. That is a good sign. So because our x values are the same, we can then say, yes, this is a parallelogram. And why? Well, the opposite angles are congruent. And if I actually plug in 33 for x, I get that this is 106. I get that this is 74. This is 106. This is 74. If you add up all four angles, we get that those equal 360, which it should. And also, if we look at our consecutive angles, they're supplementary, which is also a rule about parallelograms. If ON is equal to 7x minus 5, LM is equal to 6x plus 3, NM is equal to y minus 4, and OL is equal to 2y plus 5, find the values of x and y given that LMNO is a parallelogram. I'm going to pause the video real fast and I'm going to plug in everything that I know. All right, so since this is a parallelogram, because it told us it is, we know that these two sides have to be congruent. So I'm going to set those equal to each other. So 7x minus 5 is equal to 6x plus 3. When we solve for x, we end up getting that x is equal to 8. Now I need to solve for y, so I know that these two sides are congruent, which is 2y plus 5 is equal to 6x plus 3. When I solve for y here, I end up getting that y is equal to -9, which is okay. So here are my values. And tomorrow on the quiz, you won't get a negative value like that, so don't worry. But for this case, it's fine. All right, number 7, we are going to solve for x and y again. So the first thing I need to do is solve for y. If I look at this diagram, I know I have a linear pair here. So if the exterior angle is 114, that means that the interior angle y would have to equal 66. Okay. Now I need to look at the type of shape I have, and I have a quadrilateral because there's 4 sides here. So if I have a quadrilateral, I know that the sum of the interior angles is 360. How do I know that? Well, I have to use my interior angle equation, which is 4 minus 2 times 180. You end up getting 360. So that means that 66 plus x plus 126 plus 65 has to equal 360. So if I combine my like terms and solve for x, I end up getting that x is equal to 103. Number 8, segment WY and segment XZ intersect at A. If AX is equal to 3, AZ is equal to 3, AW is equal to 4, and AY is equal to 4, is WXYZ a parallelogram? Explain your answer. There's no diagram here, so I'm a visual person. I need to see what I'm working with, so I'm going to sketch out this parallelogram. So we know that we have diagonals going on here, and they intersect at point A, and it also tells us that AX is 3, AZ is 3, which I drew here. AW is 4 and AY is 4, which I have here. Is this a parallelogram? Well, the answer is yes. Why? Well, the diagonals bisect each other, and that is one of our theorems. So yes, because the diagonals bisect each other. And that's enough information to prove that this is a parallelogram. Number 9, we are given that UVWX is a parallelogram. The measure of angle WXV is 17. The measure of angle WVX is 29. We know that XW is 41, UX is 24, and UY is 15. We have some questions here that we need to now answer. So I'm going to make sure everything is labeled, so we're good. We want to start off by finding the measure of WVU, which is WVU is this angle measure right here. Well, we do know what this angle is, and it's 29, which means I need to figure out what is this angle measure here. Well, if I look at my diagram, I know that this is 17. So if this is 17, that means this angle is also 17 because they are alternate interior angles. These lines are parallel. So I now just need to add these two up together, and I end up getting 46 degrees. Next, I need to figure out what is WV. So WV is right there. So the opposite side is XU, which is 24, meaning that WV is also 24 if this is a parallelogram. Next, we are looking for angle XUV. So XUV is this entire angle measure right here. Well, we know that the consecutive angles in a parallelogram are supplementary. So we already figured out that this angle here is 46. So that means, and I'll just call it angle X, that if we add up angle X and angle 46, it needs to equal 180 degrees. So that means that X is going to equal 134. So we have 134 degrees for angle measure XUV. In our last question, UW, so UW is right here. If we look at the diagram, we know that this segment here is 15. So this is also 15, meaning that the entire diagonal is 30. All right, in our last question here, if AD is equal to 12, BC is equal to 12, AE is equal to 3, EB is equal to 10, DF is equal to 11, and FC is equal to 4. Is ABCD a parallelogram? I'm going to pause the video and I'm going to label all of my sides. So now for this to be a parallelogram, we know that the opposite sides must be congruent. So these ones work. But if I look at AB and DC, we notice that this is 13 and this side here is 15. So no, this is not a parallelogram because AB is not the same measure or length as DC.